Welcome to the YouTube channel of Vyasa Institute of Mathematics. In this episode, let us see the method to solve the problems on arrangements. Arrangements are also known as permutations. In most of the competitive examinations, you can see the questions on arrangements. Here in this episode, let us see some shortcut methods and other details regarding the problems on arrangements. Before going into the details of the topic's arrangement, let us see an important principle regarding the counting known as fundamental principle of counting. Fundamental principle of counting. It is a principle which we will definitely use in all the problems of arrangements. The principle is, if one thing can be done, if a particular thing can be done in m different ways, and after that another thing can be done in n different ways. The first thing can be done in m different ways, and after that another thing can be done in n different ways. Then these two together can be done in m into n different ways. If one thing can be done in m different ways and another thing can be done in n different ways, then these two together can be done in m into n different ways. This is the basic principle behind all the problems of arrangements. Whenever two things together are to be done, to get the total number of ways in which that can be done, you should multiply the number of choices of both the things. That is the fundamental principle of counting. Now let us see some problems related to arrangements. So first consider a question. In how many different ways can the letters of the word mother be arranged, taking all the letters exactly once? In how many different ways, how many different arrangements are there using the letters of the word mother, taking all the letters exactly once? That is a problem on arrangement. Here we have 1, 2, 3, 4, 5, 6 letters we have. Now these 6 letters can be rearranged. The positions of these 6 letters can be rearranged. Then after rearranging all these letters, we have to count the number of arrangements. For that, let us consider these 6 letters are to be placed in 6 boxes. Suppose we have 6 boxes here. 6 boxes here. Now we have to put one letter each in all these 6 boxes. The number of arrangements of this word is the same as the number of ways in which we can put these 6 letters in these 6 boxes with one letter in each of the boxes. First, let us come to the case of first box. When we come to the first box, we have 6 letters with us. So the letter for the first box has 6 choices. The letter for the first box can be any one among these 6 letters. Therefore, the letter for the first box has 6 choices. Now, when we come to the second box, we have only 5 letters remaining with us. One letter we have kept in the first box. Then we have only 5 letters with us. So for the letter for the second box has only 5 choices. Then when we come to the third box, we have only 4 letters with us. So the letter for the third box has only 4 choices. Continuing in this way, we can see that here there are 3 choices, here there are 2 choices, and when we come to the last box, there is only 1 choice. We will be left with only 1 letter. So we have only 1 choice. Then if we apply the fundamental principle of counting successively, if we apply the fundamental principle of counting successively, we can see that all these can be done in 6 into 5 into 4 into 3 into 2 into 1 ways. This can be done in 6 ways, this 5, this 4, this 2, 3, 2, 1. Therefore, all these together, using the fundamental principle of counting, all these together can be done in 6 into 5 into 4 into 3 into 2 into 1 ways. This expression can be written as 6 factorial. This symbol means factorial symbol, factorial. When we put this factorial symbol after an integer, after a natural number, it means it is the continued product from that number to 1. It is a continued product of all the natural numbers from that number to 1. That means if you write 3 factorial, it means 3 into 2 into 1. If you write 2 factorial, it means 2 into 1. If you write 8 factorial, it is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. That's the meaning of factorial. So here we can see that the number of arrangements of letters of the word mother is 6 factorial because there are 6 letters in the word. Now we can note that there are 6 letters in the word, therefore the number of arrangements we got is 6 factorial. Now you can generalize that principle. That means the number of arrangements of n things, the number of arrangements of n things taken all together, each exactly once, is n factorial. Number of arrangements of n things equal to n factorial. That can be used as a principle for the arrangements. If there are n things, n letters or n anythings, n persons or anything, then if there are n things, then the number of arrangements are equal to n factorial. Now, let us come to the case of another word. Say, consider the words C-O-C-O-C-O-L-A, Coca-Cola. Consider the word Coca-Cola. We want to find the number of arrangements of all the letters of this word. When we come to the case of this one, the number of letters is 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are there. But those 8 letters are not different. Those 8 letters are not different. Here, C is repeated 3 times. O is repeated 3 times. And L and A are only 1 time. Of the 8 letters, 3 letters are repeating, 3 other letters are repeating. In such cases, when something is repeated, the number of arrangements is not equal to the number factorial. Here there are 8 letters, but in this case, the number of different arrangements is not equal to 8 factorial. Here, to get the exact number of different arrangements, we have to divide this 8 factorial. 8 means number of letters. Divide the 8 factorial by each factorial of each repetition. Here C is repeated 3 times, So you divide this 8 factorial by 3 factorial. Again, one more repetition of O. That number also is 3. So we divide this by 3 factorial also. The other two are not repeated. So we can leave those. So here, out of the 8 letters, 3 letters are the same, 3 other letters are the same. Then the number of arrangements equal to 8 factorial divided by 3 factorial into 3 factorial. Now, that also we can generalize by saying that the number of arrangements of n things, in which p things are the same, and q other things are the same. That means same thing is repeated, like in the word of Coca-Cola. Then the number of arrangements equal to n factorial, total number factorial, divided by each factorial of each repetition, p factorial into q factorial, number of arrangements. Number of arrangements equal to n factorial divided by p factorial into q factorial. That means total number of arrangement, total number factorial divided by factorial of each repetitions. That is the method to do the arrangements when something are repeated. Next, let us take the case of another problem. The question is, suppose 10 persons are to be arranged in a row. Among these 10 persons, 3 persons want always to be together. Among these 10 persons, 3 particular persons want always to be together. So the question is, in how many different ways we can arrange these 10 persons? Keeping the 3 particular persons, 3 persons are to be together always. Ten persons are to be arranged, but 3 persons are always to be together. So the question is, in how many different ways we can arrange these 10 persons, keeping these 3 persons together? In such problems, I shall give you a shortcut formula for that. Before that, I shall explain how that formula is derived. Here, 3 persons want always to be together. Let those 3 persons be A, B, and C. The 3 persons, the 3 things which always want to be together are A, B, C. First, let us arrange these 3 things. Let us find the number of arrangements of these 3 things. Since there are 3 things, their number of arrangements are equal to 3 factorial. There are 3 things, so the number of arrangements of these 3 equal to 3 factorial. Now, those 3 factorial arrangements are A, B, C. It can be like this, or it can be A, C, B, or it can be B, A, C, or it can be B, C, A, or it can be C, A, B, or it can be C, B, A. These are the 3 factorial. 3 factorial means 6. These are the 6 different arrangements. Now, since we want these 3 things always together, now let us consider the group of these 3 as a single letter, as a single unit, A, C, B, or A, B, C, B, A, C. We can consider it as a single unit. Then, considering this as a single unit and 7 other persons are also there. Among these 10 persons, 3 persons are to be together. Therefore, 3 persons are to be together. Therefore, this one is treated as a single unit. Also, we have 7 persons. Then, treating this as a single person and this as another, these 7 as individual persons, we have 8 persons now. We have 8 persons. Then the number of arrangements are equal to 8 factorial. Those 3 persons with the arrangement A, C, B and treating it as a single unit and considering the 7 other persons, we have 8 persons. So the number of arrangements are equal to 8 factorial. This 8 factorial arrangements also can be formed using the arrangement ABC and using the arrangement BAC and using the arrangement BCA and using the arrangement CAB, again using the arrangement CBA. Thus in total, there are 3 factorial into 8 factorial arrangements. 3 factorial into 8 factorial arrangements. So, when 10 persons are to be arranged in a row with 3 persons always together, first we write 3 factorial. Factorial of number of persons always to be together, 3 factorial. Then we take 10 minus 3 is 7. 10 minus 3 is 7. This 7. Also then we are considering this group as a single unit. So we add one more. That means this is taken as a single person. So we add one more to the 7. That means we have 8 persons. So the number of arrangements equal to 8 factorial. Again, using the fundamental principle of counting, then we have 3 factorial into 8 factorial arrangements. This also we can generalize and let us derive a formula to find the number of arrangements in such cases. The formula is, suppose there are n things. Suppose there are n things and r particular things are always to be together. R particular things are always to be together. Out of the n things, r things are to be together. Then the number of arrangements are equal to r factorial. Factorial of the number of things to be together, r factorial into n minus r plus 1 factorial. R factorial into n minus r plus 1 factorial. This is the formula to get the number of arrangements when r things are to be together. For example, suppose we have to arrange 8 books. We have to arrange 8 books on a shelf. 8 books are to be arranged on a shelf. Among those 8 books, 2 particular books are on the same subject. Two particular books are on the same subject. Then the question is, in how many different ways these 8 books can be arranged on the shelf, keeping these 2 particular books on the same subject always together. Then here n means 8 and r, the number of things to be together, r equal to 2. So as per our formula, r factorial means 2 factorial. And n here it is 8 minus r is 2 plus 1 factorial. That means 2 factorial into 8 minus 2, 6 plus 1, 7 factorial. 2 factorial is 2, 2 into 1, 2. 7 factorial means 7 into 6 into 5 into 4 into 3 into 2 into 1. Multiplying all these, you will get the number of arrangements in this case. So these are the rules. These are the rules by which you can solve all the problems related to arrangements. Try to study these shortcut methods and all the things which I have explained here. Now let us see in the next episode, and in the next episode we will come with other topics related to the competitive examinations. Thank you very much.